This is Jupiter. You've seen the pictures, the big orange marble with the red dot. You probably learned about it in school, maybe built a model of it out of styrofoam for a science fair. Your teacher told you it was a gas giant, a failed star, and that its gravity protects Earth from asteroids like some kind of cosmic bodyguard. Here's the problem. Almost none of that is true. Over the last decade, NASA's Juno spacecraft has been circling Jupiter closer than anything we've ever sent there. And the data coming back has forced scientists to throw out almost everything they thought they knew. The inside is wrong, the surface is wrong, the famous red spot is not what you think. And the idea that Jupiter protects us, that might be the biggest lie in all of planetary science. So let's talk about what Jupiter actually is. Because the real version is way more terrifying, way more beautiful, and way more bizarre than anything in your old textbook. On July 4th, 2016, a spacecraft the size of a basketball court fired its engine for 35 minutes and slipped into orbit around Jupiter. That spacecraft was Juno, built by NASA's Jet Propulsion Laboratory in Pasadena, California, and it had just completed a 5-year, 1.7 billion-mile journey from Earth. Juno doesn't orbit Jupiter the way you'd expect. It swings in highly elliptical loops from pole to pole, diving within 2,100 miles of the cloud tops before swinging back out, completing one orbit every 53 days. Each close pass is basically a 2-hour kamikaze sprint. The spacecraft screams over the planet, collecting as much data as possible before pulling away from Jupiter's brutal radiation belts. And the instrument doing the heaviest lifting is something called the microwave radiometer, a set of 6 antennas that can peer roughly 150 kilometers below the visible clouds. That single instrument has rewritten more of what we know about Jupiter than any tool in history. By September 2025, Juno had completed roughly 76 of these close passes, and the photos alone would have been enough to justify the entire $1.5 billion mission. Because here's what nobody expected. When you look at Jupiter through a backyard telescope, you see neat horizontal bands of cream and brown separated by smooth jet streams. The planet looks almost peaceful, like a giant marble suspended in the darkness of space. Juno showed us that this is an illusion of distance. Get close to the cloud tops over Jupiter, and the serene marble transforms into something that looks like a Van Gogh painting having a nervous breakdown. The smooth bands dissolve into thousands of interlocking storms, each one larger than a hurricane on Earth, all churning and folding into each other with no clear boundaries between them. The images from JunoCam, captured from as close as 5,400 miles above the cloud tops, revealed chaotic swirling storms, folded filaments of cloud, and violent eddies evolving over just days. The colors range through vivid oranges, deep rust reds, creams, cobalt blues, and whites. Scientists still don't fully understand what produces the red and orange tones. The leading theory involves sulfur and phosphorus compounds being broken apart by ultraviolet light, but the exact chemistry remains one of Jupiter's stubbornly unsolved mysteries. And then Juno looked at the poles. Nobody had ever gotten a clear view of Jupiter's poles before. What they found there genuinely shocked the entire planetary science community. The familiar banded structure just stops. It vanishes completely. And in its place, you see enormous cyclones arranged in perfect geometric patterns. At the North Pole, one central cyclone sits surrounded by 8 others, forming an octagonal shape, each storm roughly the size of the continental United States. At the South Pole, 5 cyclones form a near-perfect pentagon, and these are even bigger, between 5,600 and 7,000 kilometers across, with wind speeds hitting 350 kilometers per hour. The wild part is that these cyclones are packed so tightly together their spiral arms literally touch. But they never merge. They've maintained this geometry for the entire decade Juno has been watching. Each cyclone is surrounded by a ring of counter-rotating winds that pushes neighboring storms away, like 2 magnets repelling each other. When one drifts too close, it bounces back. Scientists at Caltech describe the motion like springs. Nothing like this exists anywhere else in the solar system. And honestly, nobody fully understands why they're so stable. Now, before we go deeper into Jupiter's interior, we need to kill some myths. And the first one is a big one. You've probably heard someone say that Jupiter is a failed star. It sounds cool. Jupiter is made of hydrogen and helium, just like the Sun. It even radiates about 1.6 times more energy than it receives from sunlight. So it almost became a star, right? Not even close. Jupiter would need to be 75 times more massive than it currently is to ignite hydrogen fusion and become even the smallest, dimmest red dwarf star. It would need 13 times its current mass just to be classified as a brown dwarf. Saying Jupiter almost became a star is like saying you almost won an Olympic gold medal because you own a pair of running shoes. The physics aren't even in the same category. Stars form through the top-down gravitational collapse of gas clouds. Jupiter formed bottom-up, through core accretion, where rocky material clumped together first and then gravitationally swept up a hydrogen and helium envelope. Completely different process. The second myth is even more dangerous because people still repeat it constantly. The idea that Jupiter acts as Earth's cosmic shield, using its massive gravity to deflect asteroids and comets away from us. This was popularized by a 1994 study and cemented by the book Rare Earth in 2000. It became one of those facts everybody just accepted. Then Kevin Grazier at NASA's Jet Propulsion Laboratory actually tested it. His simulations, published in 2016 in the journal Astrobiology, tracked 10,000 particles in the gaps between the outer planets over 100 million years. The result? Jupiter is just as likely to fling comets toward Earth as it is to deflect them away. In a follow-up 2019 paper analyzing over 2.6 million close planet particle interactions, Grazier argued that a Jupiter family comet, the kind Jupiter's gravity actively creates, is at least as likely a candidate for the impact that killed the dinosaurs 66 million years ago as a comet from the distant Oort cloud. So Jupiter isn't our bodyguard. It might be the reason the dinosaurs went extinct. If anything, Jupiter's most important role was probably delivering water and organic compounds to early Earth. Less cosmic shield, more cosmic bartender. If you're finding this interesting, do me a favor and hit subscribe. I cover space and science like this every week, and I promise you the next part gets even wilder. Now let's go inside Jupiter, because what Juno found in there broke planetary formation theory. The old textbook picture was simple and clean, an atmosphere of molecular hydrogen sitting on top of liquid hydrogen, which transitions to metallic hydrogen deeper down, which surrounds a compact rocky core about 10 times the mass of Earth. Neat layers like an onion. Juno's gravity measurements destroyed that picture. By tracking tiny changes in Juno's radio signal down to 2 micrometers per second, scientists mapped Jupiter's internal gravity field with incredible precision. The critical finding was that certain gravity harmonics were unexpectedly weak. A compact core couldn't produce those numbers. The solution is what scientists now call a fuzzy core or dilute core. Instead of a neat ball of rock and ice at the center, heavy elements are gradually dissolved and mixed with hydrogen and helium across a massive region extending 30 to 63% of Jupiter's entire radius. There's no sharp boundary between core and envelope. The deep interior is just a thick soup of everything blended together. A dramatic 2019 paper published in Nature proposed that an ancient head-on collision with a planet 10 times the mass of Earth shattered Jupiter's original compact core and stirred the debris throughout the interior. But in August 2025, researchers at Durham University ran improved simulations and found the heavy material settles back down too quickly after an impact. The fuzzy core probably formed gradually as Jupiter grew, not from a single catastrophic event. And the material filling the bulk of Jupiter's interior is something that sounds like it belongs in science fiction. It's called metallic hydrogen. Under pressures between 50 and 400 gigapascals, at temperatures between 5,000 and 8,400 Kelvin, hydrogen gets squeezed so hard that its electrons break free and start flowing like a liquid metal. This isn't a solid and it isn't a gas. It's a shimmering metallic ocean that makes up roughly 75 to 80% of Jupiter's total mass. At the very center, pressure reaches about 4,000 gigapascals, which is 40 million times the atmospheric pressure on Earth's surface, and temperature hits around 20,000 Kelvin. Here's a detail that messes with people. Jupiter has no surface, None. At no depth do you encounter a boundary between gas and liquid. If you somehow fell into Jupiter's atmosphere, you would never splash into anything or land on anything. The material just gets denser and denser and hotter the deeper you go, like sinking into an ocean that has no top and no bottom. The gas you flew into gradually becomes a liquid without ever crossing a boundary, because the conditions pass through hydrogen's critical point where the distinction between gas and liquid simply ceases to exist. Jupiter is technically mostly liquid. The gas giant label is honestly kind of misleading. Liquid metal world would be more accurate. That ocean of metallic hydrogen also generates the most terrifying magnetic field in the solar system. Jupiter's magnetic field is 20 times stronger at the surface than Earth's, and its magnetic moment is 20,000 times larger. But when Juno got close, it measured a peak field strength of 7.766 Gauss, fully 50% stronger than any model had predicted. The field turned out to be wildly asymmetric, with the northern hemisphere far messier and more complex than the south. The strangest feature is something called the Great Blue Spot, an intense patch of magnetic flux near Jupiter's equator that drifts eastward fast enough to circle the planet in about 350 years. It was the first detection of a changing magnetic field on any planet beyond Earth. Jupiter's magnetosphere, the bubble of space controlled by this magnetic field, is the largest coherent structure in the solar system after the Sun's heliosphere. It stretches up to 3 million kilometers toward the Sun, and its tail extends over 1 billion kilometers in the other direction, nearly reaching Saturn's orbit. If you could see it from Earth with the naked eye, it would look several times wider than the full moon in the night sky. The entire Sun, corona and all, would fit inside it. And the volcanic moon Io, orbiting deep within this magnetic bubble, pumps up to 1,000 kilograms of sulfur and oxygen into the magnetosphere every single second, feeding a donut-shaped ring of million-degree plasma called the Io plasma torus that co-rotates with Jupiter at 74 kilometers per second. Inside that magnetosphere, the radiation is absolutely savage. When Pioneer 10 flew past Jupiter in 1973, it absorbed 200,000 rads from electrons alone. A lethal dose for a human is 500 rads. Voyager 1 received 1,000 times the lethal human dose. Juno survives inside a titanium radiation vault with 1 centimeter thick walls, and even then, it can only spend about 2 hours near the planet before pulling away. Jupiter's auroras make Earth's northern lights look like a nightlight. They're permanent, always on, powered primarily by Jupiter's own rotation rather than the solar wind. Each aurora is physically larger than the entire Earth, and they pump out 10 to 100 terawatts of energy, which is more than all of human civilization's power output combined. In 2021, scientists finally solved a 40-year mystery about Jupiter's X-ray auroras, which pulse every 27 minutes. The cause turned out to be solar wind compressing the magnetic field and launching electromagnetic waves. That sulfur and oxygen ions from the volcanic moon Io ride like surfers down the field lines before slamming into Jupiter's atmosphere. Speaking of things that are changing, let's talk about the most famous feature on Jupiter, because the Great Red Spot is dying. In the late 1800s, the Great Red Spot measured roughly 41,000 kilometers across. That's 3 Earths wide. When the Voyager spacecraft flew past in 1979, it had already shrunk to 23,300 kilometers. By 2017, when Juno arrived, it was down to 16,350. And by November 2023, amateur astronomer Damian Peach measured it at approximately 12,500 kilometers, smaller than Earth itself for possibly the first time in recorded history. It's also getting rounder. Starting around 2012, the shrinkage accelerated to roughly 930 kilometers per year, and fragments began flaking off the edges in 2019. Juno flew directly over the Great Red Spot in July 2017 and produced the first 3-dimensional view. The microwave radiometer showed the storm extends at least 240 kilometers below the cloud tops, and gravity measurements constrained the total depth to somewhere between 300 and 500 kilometers, up to 100 times deeper than Earth's oceans. Wind speeds at the edges reach between 430 and 680 kilometers per hour. Then in 2024, the Hubble Space Telescope made a startling discovery. The Great Red Spot oscillates. It squeezes in and out with a roughly 90-day period, while simultaneously speeding up and slowing down, like a bowl of gelatin vibrating on a table. Nobody had ever detected this behavior before. A 2024 study also found the spot may be much younger than we thought. A 2024 paper by Agustín Sánchez Lavega showed the permanent spot observed in the 1600s was probably a different, smaller storm. There's a 118-year gap with no confirmed sightings. The current Great Red Spot might be only about 190 years old, younger than many countries. And Juno found something even stranger happening in Jupiter's weather. Something scientists literally named mushballs. Every textbook said Jupiter's lightning happened deep in the water clouds, 45 to 65 kilometers below the visible surface. But Juno detected lightning at much higher altitudes, in ammonia water clouds where only ice should exist. The explanation? Ammonia acts as antifreeze, melting water ice into liquid droplets that collide with ice crystals and generate electrical charge. This discovery, published in Nature in August 2020, was called shallow lightning. The same research spawned an even weirder concept. In Jupiter's massive thunderstorms, ammonia and water combine to form hailstones roughly the size of softballs, about 2/3 water and 1/3 ammonia, with a slushy core encased in water ice. These mushballs grow in updrafts, then fall deep into the atmosphere and evaporate, dragging ammonia down to depths where Juno's instruments can't detect it. This solved the mystery of Jupiter's missing ammonia, which had been depleted far deeper than any known process could explain. UC Berkeley researchers spent 3 years trying to disprove the mushball theory before confirming it with comprehensive three-dimensional atmospheric modeling in April 2025. Oh, and while Earth's lightning clusters near the equator because the sun heats the tropics, Jupiter's lightning concentrates at the poles. The planet's own internal heat drives convection most freely where the sun's warming influence is weakest. Now let's zoom out to Jupiter's moons, because one of them might be the best place to look for alien life in the entire solar system. Europa is a little smaller than Earth's moon, but beneath its cracked icy surface lies a saltwater ocean estimated at 60 to 150 kilometers deep, containing more than twice the water in all of Earth's oceans combined. The ice shell above it is estimated at 10 to 25 kilometers of brittle outer ice, plus potentially another 40 kilometers of warmer convective ice below. The surface is geologically young, only about 40 to 90 million years old, meaning something is constantly resurfacing it from below. In September 2023, the James Webb Space Telescope detected carbon dioxide concentrated in a region of Europa called Terra Regio, a chaotic terrain area where the ice shell appears disrupted. The analysis showed that carbon originated from the subsurface ocean, not from meteorite impacts. That was a landmark finding for habitability, because carbon, liquid water, and an energy source are the three ingredients for life as we know it. Europa might have all three. NASA launched Europa Clipper on October 14, 2024 on a SpaceX Falcon Heavy. This $5.2 billion spacecraft, the largest NASA has ever built for planetary science, will arrive at Jupiter on April 11, 2030. It will perform 49 close flybys of Europa, some as low as 25 kilometers altitude, using ice-penetrating radar to probe the ice shell structure. The mission almost didn't happen. In May 2024, engineers discovered that critical transistors throughout the spacecraft failed at lower radiation doses than specified. A team worked around the clock for 4 months and figured out the transistors self-heal when heated between radiation exposures. No hardware needed to be replaced. Meanwhile, Juno's close flybys of the volcanic moon Io in December 2023 and February 2024 overthrown another long-held theory. Scientists had assumed Io had a global underground magma ocean. It does not. Instead, each of Io's 150-plus active volcanoes is powered by localized magma chambers connected through a maze of rocky tunnels. And on December 27, 2024, Juno detected the largest volcanic eruption ever recorded in the solar system, a lava outpouring covering 40,000 square miles on Io's surface, producing more energy than humanity's total annual output. It was still going in March 2025. And then there's Ganymede, the largest moon in the entire solar system at 5,268 kilometers in diameter, bigger than the planet Mercury. It's the only natural satellite with its own magnetic field, and Hubble observations confirmed it harbors a subsurface ocean roughly 100 kilometers deep, 10 times deeper than Earth's, buried under 150 kilometers of ice. Juno's June 2021 flyby revealed previously unknown impact craters and detected mineral salts and organic compounds on the surface. The European Space Agency's JUICE mission will eventually orbit Ganymede, becoming the first spacecraft to orbit a moon other than our own. Here's one more thing almost nobody knows. Jupiter has rings, actual rings. They were discovered on March 4, 1979 by Voyager 1, making Jupiter only the third planet known to have a ring system at the time. The rings are made entirely of dark reddish dust, not ice like Saturn's, kicked off 4 tiny inner moons by micrometeoroid impacts. They're about 1 million times fainter than Jupiter itself, which is why you've probably never heard of them. The James Webb Space Telescope captured them in infrared in July 2022, producing one of the clearest images of Jupiter's rings ever taken, with the tiny moon Adrastea visible as a speck alongside background galaxies shining through the thin ring material. A 2022 study by Stephen Kane explained why Jupiter can never develop Saturn-like rings. The massive Galilean moons create gravitational perturbations that would clear out ring material within about 1 million years. Big planets make big moons, and big moons destroy rings. JWST has also opened an entirely new window on Jupiter's atmosphere. In 2023, it discovered a previously unknown jet stream at 320 kilometers per hour, sitting 40 kilometers above the main cloud deck, spanning over 4,800 kilometers wide. And in 2024, JWST observed the region above the Great Red Spot and found unexpected dark arcs, bright spots, and dynamic bands in what scientists had assumed would be a boring, static layer. Jupiter's atmosphere, it turns out, is active and connected from top to bottom in ways nobody predicted. So where does all of this leave us? Jupiter is not the calm, smooth marble from your classroom poster. It's a liquid metal world wrapped in continent-sized cyclones arranged in impossible geometric patterns. It harbors a dissolved core that defies formation theory. It generates radiation that would kill an unprotected human in minutes. It's surrounded by moons with more liquid water than Earth. The Great Red Spot, probably younger than the United States, is visibly shrinking and wobbling like gelatin. Softball-sized ammonia hailstones are falling through an atmosphere where lightning crackles at the poles. And far from protecting Earth, Jupiter may have flung the very asteroid that ended the age of dinosaurs. Every single one of those facts was either unknown or wrong in textbooks printed before 2016. We went from thinking we understood the largest planet in our solar system to realizing we barely knew it at all. Europa Clipper is on its way right now, crossing the inner solar system. The European Space Agency's JUICE mission launched in April 2023 and will arrive at Jupiter in 2031, eventually becoming the first spacecraft to orbit a moon other than our own when it enters Ganymede orbit in 2034. JWST keeps watching in infrared, finding things Juno's cameras can't see. And Juno itself, battered by years of radiation, may still be transmitting from its orbit around the most extreme planet we've ever studied. The next 5 years are going to rewrite the textbooks again. And if this video showed you a Jupiter you didn't know existed, subscribe, because we are just getting started.